Hello, we're Team One Step, team number 915. My name is Christian Ishiki, and I focus on engineering and materials.
My name is Jacob Andal, and I focus on engineering and 3D CAD.
I'm Christopher Gomez. I specialize in optimizations, robotics, and angle calculations.
My name is Sahir Kadri. I specialize in computer science and AI.
My name is JJ, and I specialize in circuitry and design.
This is our co-designer, Mr. Ishiki, who's my father. He used to love to go golfing and fishing. However, a few years ago, he had an infection develop in his right leg due to diabetes, which resulted in an amputation above the knee. This made him completely dependent on his prosthetic.
After multiple interviews, we found the two most glaring problems with Mr. Ishiki's current prosthetic. The first is that his current prosthetic lacks a motorized knee. So if he wants to take a step, he needs to use his thigh to manually kick out his shin, which is fatiguing even over short distances. And the second is that his current prosthetic supports his weight with a hydraulic pressure-based system in his knee, but it only activates if the shin forms a straight line with his thigh. So if Mr. Ishiki gets too fatigued and tries to take a step without making this straight line, there will be no resistance in the knee to support his weight. And when he puts his foot down, he'll fall over.
We decided to solve these problems by building a rehabilitative walking device for Mr. Ishiki. Ideally, this device would 1. Read his walk cycle and detect when his thigh is moving forward, and 2. Send the input data to a motor, which extends his leg for him, activating the resistance and allowing him to walk naturally without having to kick his prosthetic forward. Our initial prototype just used one IMU placed on the thigh of his leg, which analyzed the velocity at which his leg came out. However, we realized this was too inaccurate, so we decided to add a second IMU on the shank of his leg. After adding one more IMU to the shank and one on his thigh, this would allow us to more accurately determine the flexion of his knee. However, this didn't let us know whether to move the knee forwards or backwards. For our third and final prototype, we had a Raspberry Pi, which obtained the two readings from the two IMUs and used that to calculate a pulse modulation from the angle. This would send the pulse modulation through binary encoding to the Arduino, which was connected to a motor driver, telling the motor to extend either forward, backwards, or not at all.
The circuitry for our final prototype utilizes jumper wires. Firstly, male-female jumper wires connect the Arduino to the Arduino Uno. Then, male-male jumper wires connect the Arduino to the motor driver in order to send a PWM signal. Then, the motor driver is connected to the motor with more male-male jumper wires. The Raspberry Pi is powered via a power supply connected to an outlet, and the Arduino is powered by USB connected to the Raspberry Pi. The motor is also powered by a 12-volt battery connected to an outlet. The electrical mechanical system is contained within a 3D printed circuit box.
The physical work of the device comes from the motor, which will be placed on Mr. Ishiki's hip to minimize weight from leverage. When the motor is activated by the IMU, it begins to turn these gears. We used a belt and pulley system to transfer the force over a longer distance, and that makes the whole device lighter since we're using less gears. And over here, closer to the shaft, we use a 1:2 gear ratio to transform speed from a smaller gear into torque for a larger gear. You can see it work like this. I'm turning the taller gear, and when Mr. Ishiki turns his leg out, it'll kick out. When in use, we plan to cover the whole thing with a 3D printed shell to protect it from dust and water.
Since we were only able to finish a model, we hope to come up with a working device that Mr. Ishiki can use in the future. Mr. Ishiki isn't just a co-designer, but a dad of our friend who we hope to help as much as possible. This project taught Chris and I a lot about working with technology we were previously unfamiliar with. From learning about IMUs to working with an Arduino, we were introduced to a broad range of concepts we wouldn't have encountered anywhere else.
This project introduced me and Christian to practical engineering skills, like drilling through various materials and proper safety procedures when using power tools.
A challenge pushed me to learn circuitry and electrical engineering from the ground up, fostering skills in circuiting, soldering, and 3D printing. However, the most important skill that we learned from the Create Challenge was the importance of helping others with technology, bringing out the best in humanity, empathy, and compassion.
To fundraise for our materials, we collaborated with a local business to design and sell the shirts that we're currently wearing. With their assistance, we were able to sell over 50 shirts to our friends and family and fundraise over $400.
We'd like to thank some organizations and people who helped us, such as Whitney High School Robotics,
Mr. Singh, our coach,
J2K Collective for designing our shirts,
Mr. Gomez for tutoring us in circuitry,
and you for watching this video.